Oh my goodness, you guys, I am so excited. We get to do the chain rule today. This one's a whopper. Oh man, it's such a great rule to learn with derivatives. I'm so excited for us to learn this today. Okay, so let's jump right in. Here is the mathy way to write this. If we have dy dx, right? So we know that this is the derivative of y with respect to x. So that's what we're talking about. The chain rule says I can have dy du times du dx. Okay, so here's what this means. This means I'm looking at an inside function. So here's another way to write this. So the derivative with respect to x of f of g of x. I've got this inside function. All right? So that is derivative of the outside, keeping the guts, times the derivative of the inside. All right, let me write this down. So we're going to take the derivative of the outside function, keep the guts. That's my, technical term. I like to use. Keep the guts. Then multiply it. Multiply by the derivative of the inside. Okay, so take the derivative of the outside, keep the guts exactly the same. So just take the derivative of the outside, that f prime of x. This is saying the outside function, my dy, my f, my outside, times the derivative of the inside. So I'm taking the derivative of the outside with respect to the guts, keep them the same. Then I take that times the derivative of the inside. So I'm taking the derivative of the inside with respect to x. That's just notation. All right. I just want to make sure you understand. Sometimes chain rule has this kind of notation. Sometimes chain rule has this kind of notation. All right. Just notation. This is what we're going to take. The derivative of the outside, keep the guts, multiply that by the derivative of the inside. So we're going to do some examples. So let's do it right now. Here's example 1. Find the derivative. Here's part A. I have y equals fx plus 4. Pardon me, I said f. Doggone it. Y is equal to 5x plus 4 to the 3/2 power. So think back when we were in the review chapter and we had to identify outside functions and inside functions, right? Welcome to why we did that. Welcome to why we did that. We did that because now, if I know what an outside and an inside function are, then I can do my chain rule. So if I find this derivative, I have y prime or dy dx, whatever. My outside function here is this exponent. So I'm going to keep this guts as though this were like a u, as we used as a variable before, or something. I'm going to keep those guts. When you do the power rule, you bring it in front and subtract 1 from it, right? So I'm going to bring that 3/2 in front. Keep the guts. Oh man, I can't express that enough. Keep those guts. Then you subtract 1 from the exponent. And then that's where I get my 1/2. But we're not finished yet. That's only the outside. Then I come in here and say, I now multiply by the derivative of the inside, right? We took the derivative of the outside, kept the guts. That happened here. Now I focus on the inside, and I just multiply by the derivative of the inside. So the derivative of 5x plus 4 is 5. Right? Then you just combine those terms together and you get y prime is equal to 15/2 and 5x plus 4 to the 1/2. It's all multiplied, so I can multiply those numbers together. And there it is. All right? Identifying the outside and the inside is going to make a huge impact for our chain rule. Do I have enough room there? Maybe, but I'm not going to chance it. Let's go to the next page. There's no need to squish us up, right? Okay. Here's example 1b. Of course, we're going to find the derivative again. And I have y is equal to sine cubed of x. Now, 98% of success in mathematics is what? That's right, organization. I find it sometimes helpful to rewrite this to be the sine of x to that third power. Do you see that? Anytime your exponent is between the sine and the angle measurement, or the trig function and the angle measurement, that is telling me that I'm taking the exponent to the whole thing. If, I guess maybe like that, I just had this cubed, then that would only be to my inside function. Do you see that difference? Okay, so let's try this one. So if I know this is going to that outside function, then, yeah, derivative of the outside, keeping the goods, times the derivative of the inside. So the outside is just a power rule. Bring the 3 in front, and I have sine x squared. Keep those guts. Man, I can't express that enough. Keep those guts. Identify that outside and inside. Because once you keep those guts, then you take that derivative. And you get cosine x. Right? So now I have 3 sine squared x cosine x as my derivative. It's not so bad, right? It's just that process, right? We know the process of the power rule. We know the process of the product rule. We know the process of the quotient rule. All of those processes we now use. As soon as you learn one, we're going to use it, right? Keep building on that foundation, this developmental calculus. We're going to keep building up that foundation. Okay, here, let's do another one. Example 1c. We have y is equal to the sine of x cubed. Oh man, look at me. I was so good. I talked about it, and here it is. Should have paid attention, huh? Check it out. The key to this one is recognizing notation. You know I harp on that, right? Harp, harp, harp. Where is my exponent? Here it's between the two, so means the whole thing is cubed. Here it's just to that inside function. So on this problem, when I say what's my outside function, yeah, that's my trig, right? That's my sine. So the derivative of sine is cosine. Good. Keep those guts. Keep those guts. I wrote the wrong letter almost, or the number, I mean. Keep those guts. I can't express that enough. Just look at the outside. Keep the guts. Then you multiply by the derivative of the inside here, which is your 3x squared. Now, it's standard practice, so you don't think you have more inside function, to write that 3x squared as a coefficient. Do you see that? And that's our final answer. That's a prime. Okay. So far, so good, right? Yes. Okay, we're going to do lots more examples.